For everybody else, I'm going to get my stuff ready. All right, so it's 12 o'clock. And Control Q. Okay, there's the Menti code for sign in. And welcome to our discussion on generator applications and protection. We are going to, I'm fidgeting with my my cell phone here. Dadgummit. Okay, welcome to generator applications and protection. We are going to have a I'm reading. I gotta not look at chat. We're gonna have a great session today, hopefully on generators, applications, and protection for everybody who is on WebEx. Your microphones are muted, so you cannot talk, but I can. The tape is off. For those of you on YouTube land, I don't have to worry about that. So please, the WebEx people, don't hit that microphone, which you guys and gals have been great at. I do have to say that although I am a member of two code-making panels on NFPA 70, code-making panel 2 and 10, I've also just been appointed to NFPA 110 and NFPA 111. So I'm on NFPA 110, 111, 78, 1078, 70B, etc. I speak on my behalf. What you hear is my opinion, no one else's. It's not the opinion of any code-making panel members, NFPA, or anybody else other than myself. Please use the chat if you don't agree with something and sometimes I misspeak. Please, forgive me. But watch that chat on YouTube and on WebEx. I know that you guys have been doing great over the last few days. So this has been absolutely fantastic with the chat sessions. So please keep that up. All right, so we are going to talk about generators and what I am going to do, and which I did not queue this up, but I usually, if anybody is, for most of those people who are familiar with what this program, I typically go over the quiz because there was a free quiz at the beginning. I am going to just give you the code for those who are kind of new to this. What I do is I put this code out. If you're familiar with, if you've got the email on my for the announcement of this, if you signed up, you were sent an email that had a link to this, or you can go to menti.com and type in 60, 13, and 3, and take the quiz. It's an anonymous quiz. And what I am going to do this time is when I built the questions into the presentation. So rather than go through the quiz Q&A at the beginning and then go into the presentation, I'm going to wait until I get to the question in the presentation. We'll call this up, see what the survey says, and then we will see what the right answer is. Because I've tried to make it align with the materials. So take that code down, 60, 13, and 3. This is not the registration. This is not the final thing that's going to ask you for your name. This is not the sign-in sheet. This is the general questions that we do, which is anonymous. All right. So that's sort of how we're gonna. This is totally different than what I've done before. All right, so 60, 13, and 3. Answer those questions, and we will. When I come up to those in the PowerPoint, we will review what all of you are saying. So let's do this. Let's talk about some of the codes and standards associated with this topic. You see there's UL 1008. Now, what I did here in this slide, actually a good friend of mine put this together, who's not with us any longer, unfortunately. He's a good man, but he looked at these standards and said, you know, how do they associate with? Are they a designer? Are they an electrical inspector? Are they the manufacturer type of deal? And when you look at these different, whether it's a UL standard, that's obviously it's a manufacturing thing from a to make sure that the standard for the product, that the product's made to the standards and whatnot, but also has the inspectors will help enforce the different types of requirements that are in the standards. Designers will use EGSA 1000 or 100S, which is a performance standard. International agencies use the ISO and IEC standards. The IEEE color books, I got them behind me. I have I just stepped away because I had to grab my books. I didn't have them open. All right, got them. All right, so we got I got the IEEE Orange book. And the IEEE Orange book, which again, these books are being rewritten. Basically, they're turning them into DOT standards. So, but I have these a physical copy, and I have electronic copies of newer versions. This one, my library. If you were on the call yesterday, my library is from 1987 and 1990. 1990, because I bought these color book sets. I think I bought these color books in 1990. It was after an internship. I graduated my college in 1990 with a power systems engineering degree, and I did a short circuit coordination and a short circuit study and a selective coordination study by hand, and then I used SKM at that time. But in that process, I fell in love with he gave me the red book and he gave me the buff book, and I read those and I'm like, man, I got to have this in my library. So I bought a whole set. But the three books that I would say are directly related to this topic are your IEEE Orange book, which is IEEE Standard 446. And it's titled Emergency and Standby Power Systems for Industrial and Commercial Applications, because we're talking generators. Standby power is appropriate. I would say the healthcare, the white book, IEEE white book, Electric Systems in Healthcare Facilities. I believe hospitals have a lot of generation, local standby generation. IEEE Standard 602, and again, this is the 1986 version, but they have newer versions. And then the other one is is IEEE Standard 493, which is the design of reliable industrial and commercial power systems. And this is the gold book. Very good. These are three decent, good references. They have been updated. So if you are an IEEE member, you can go out to IEEE Explore, and I believe you can purchase those. I don't think they're a free download, even if you're an IES member. I know you can get papers, IEEE papers, which a lot of the material in these books was drafted originally in papers. So, but in IEEE papers. So in any case, those are three good references for you. But a lot of those books are used by designers to help the performance and establish performance requirements around power distribution systems. And remember, if you're talking about generators, there are code requirements, which we will talk about a lot about National Electrical Code requirements. But a lot of what drives the application of generators is not necessarily what the code is telling you. It's the reliability that the end user wants out of the power distribution system. Whether you're at home and you want that, or if you are in an industrial facility where you say it's not required, it's not legally required, it's not a life safety issue for me, it's all about dollars and cents, about making sure I don't go down, and I have my production is still in play. And then there's NEMA documents or performance focus ICS 10. I believe that might be a free download. I don't know if I downloaded that one. And then you have obviously the NFPA documents 2070, which I have those on this next slide. NFPA 20 is for stationary pumps or fire protection. We all know the National Electrical Code. We love that document, right? And then you have NFPA 99, which focuses on healthcare facilities, and 110, which is your standard for emergency and standby power systems. Now, another key document, two other key documents, I would say, but one in specific would be NFPA 70B for maintenance. I'm on that committee. We are in the process of updating that document, and we're taking NFPA 70B for maintenance from a you could, you should, you might want to a you shall document. So we're taking it from a guide or a guide to a requirement, a standard, so that it can, because I call it the trilogy. You have NFPA 70, which is the National Electrical Code, 70E, which is electrical safety, and you have 70B, which is maintenance. Those three work together to help build a very good, safe electrical system. NFPA 30, thank you, Kevin, for fuel storage and the International Fire Code. Exactly. So, and another important thing, I know in New York, I know we got some people from New York that can maybe comment on this. We had remember the hurricane and the enormous flooding issues that we had in New York a few years ago. That drove a change in New York City's standards. And I know in Hurricane Sandy, yes. And so I remember talking to Frank Coluccio, and they were talking about, he was the chief electrical inspector at the time, and he was talking about the design changes, and they were putting the generators and whatnot out of the basement up onto higher floors, but the fuel was still down on the bottom. And that presented a challenge because, they moved the generators up for emergency power for obvious reasons, get it out of the basements, which were flooding. And, but the fuel was still, the source was still down at street level or underground or wherever, and was still susceptible to flooding issues. But in any case, your fuel is a very good, important resource when you're talking generators, right? You don't want to run out of that precious material to keep it running. All right. If I missed any standards, which 30 was one of them, if there's anything else you can think of, put it in the chats either on YouTube or out there in WebEx land. I'm just going to check the YouTubers. 70B rather than a performance code. Making 70B a prescriptive code rather than yes. So 70B is going into a requirement. So the 70B is again on maintenance. And how it's typically been used, it's sort of like a guide and a practice, not a code. So it's not necessarily a performance request code. I don't think you would call it a performance. I guess you could. It's an actual. Here's what you shall do this to maintain your equipment. Okay. All right. So, and then there's FEMA. I see Mr. Abbasi is pointing out that FEMA requirements are included into the building code in New York, which is that's an interesting perspective too. I never thought about that, Mather. Awesome. All right, let's keep this party started. So why backup power, right? I took this picture from my dashboard coming home one day, or actually, I think I was going to work, and I had left the house, which I had an outage because of a downed power line, but one of the reasons, there are a lot of different reasons, backup power is all about reliability. And there are a lot of different reasons why your power will go out. And there's, when you think about from across the country perspective, there are a lot of resources that help us understand what happens in with regard to reliability. How many events, this is a map. I'm not sure how old this was. But it's something that I've had in my presentations for a while. So this is a pretty old map, but I just updated some of the data from last night. So I found another good resource that sort of gives you an overview, and what they're seeing is a trend in outages. So uh, I think my next slide, and it was, so what they're basically saying is from 2000 to 2014, we've seen an increase in the number of outages and the duration of outages because of weather and other issues. And one of the things that they're claiming is that we have an aging infrastructure, which might be true. And if I was a utility guy, I might want to argue with you. I don't know. Or I might want to say, yeah, you're absolutely right. But in any case, there's some of the numbers that they reported. And what's interesting to me was 2000. So these are in 4-year pops, and except for, I think they're in 4-year pops, 10, except for the 2010 to 2013. But they throw in the 2014 first 6 months at least from this report. But you're seeing that the grid outages per year are increasing, and this was from that same report that talked about trying to understand why they're seeing this increase in grid outages. And one of the issues is we're seeing much more catastrophic natural disasters, and then the other, what they're trying to argue, is that we're seeing an electrical infrastructure that is challenging. It's aging. So in any case, what we do know is that outages are going to happen, and in some instances, you take a look at healthcare or any life safety emergency type of system that you're going to rely on power to get something done, either get out of a building or sometimes there's a safety in a process in an industrial facility where you say, if this process goes down, I could hurt somebody, so I got to make sure that this thing is running at all times. Or there could be environmental issues too. There are a lot of different reasons to have that backup power, but we have to plan for that outage. Your design goals, again, it's about meeting a level of reliability and simplicity. There is power in simplicity from a reliability perspective. So trying to keep things as simple as possible is very important. That's why I think if you think about like an article, if you're designing an Article 700 system, a 701 or a 708 system, you really want to question all the loads that you have on your emergency system, whether or not they truly should be there, and how can you simplify that overall reliable power system. And you got to think about your loads with regard to how much of an outage can I take. If I'm looking at data, which might not be life safety, but if my computer goes down, then any glitch, I may have to have a UPS in the picture so that I can live through any outage until I get backup generator on. And then how much time do I have? So you have to understand not only how often are you going to have an interruption, how long of a duration between when the power goes out and when the power comes back on again. All of those great things play into role to help you understand the level of performance for the customer, whoever that customer might be, let alone the code. I mean, my thought process always is, and I think as design engineers, we sometimes may use the NEC as a crutch, where we go to the National Electrical Code and say, what am I supposed to do? As opposed to talking to your customer and saying, what do you want? What do you want out of the performance of this power system? Design it to meet what your customer wants, and then make sure it doesn't violate the National Electrical Code, because your customer may want a level of reliability that's not necessarily required by the code. So let's talk about the backup system. You have your generator, but it's not just about the generator. So, I struggled a little bit in putting this slide deck together. I've given this a few times a while ago. So I was pulling from materials that I've had, and I struggled with trying to say, do I want to just focus on the generator? But if I just focus on the generator, I don't really get the entire picture of what the backup system really is. So a backup system incorporates a lot more than just the generator. You have a generator, you have your loads, you have your primary source, your generator is your alternative source, and you have that transfer switch that's in between that has to say, when something happens, here's what you need to do. And there's rules around the generator. There's rules around those conductors that feed that generator. And there's rules around that transfer switch, which all play a part in the system reliability. And we're going to talk about all of that. Now, the other thing I'll throw in is the whole aspect of that UPS. Now, I talk about a UPS system, which obviously, you know, you're going to have batteries and et cetera. But there's also a drive. I know in healthcare, they just passed some new code language to recognize alternative energy solutions, including photovoltaics and other types of similar power sources, alternative power sources to the primary source, as possible options for backup power for healthcare environments that possibly can help you live through it. And I was shown a drawing recently, which I thought was really cool. They had backup generation, they had a photovoltaic system, and they had a series of transfer switches that basically, if you lost power from the utility, you got power from the photovoltaic and the batteries, the PV system and the batteries that were there. And then when that was depleted, if that took, if the outage was long enough that you depleted your battery and, you don't have sun and you're not generating enough power from the photovoltaics, then a generator would start. So there's simple and there's complex solutions to help leverage alternative energy sources and other types of sources in a backup system. But again, I always go back to keep it simple, stupid, right? You've got to keep the simpler the design, the simpler the solution, the less that can go wrong. I even sometimes, I know at one time I was looking for a vehicle. I wanted no air conditioning. I wanted no power windows. I wanted no power steering. I wanted a manual transmission because if you think about a vehicle, those are the things that go wrong, right? And I wanted simplicity because I didn't want any of those failures. I wanted a long-term truck, basically, that was going to be a work truck that didn't have the ginger on it and all the bells and whistles, because the bells and the whistles are the first thing that fail. So the more complicated you make something, the more opportunities for failure. So in my mind, I'm a conservative engineer with regard to a lot of these things. I like to keep my designs as simple as I can. The basic logic and process of these systems. When you have an outage, so your utility source goes out, your transfer switch will turn on, and then you will feed the power to those loads. Now, I will say the loads that you select, now sometimes, and we're going to talk about this, but sometimes you'll supply power to the entire power distribution system, and sometimes you'll have just a sub panel or just a series of panels that only serve the loads that you want to be backed up. What that does for you is it helps you reduce the size of the generator. So when I built my house in Pennsylvania many years ago, I was out in the country and I got a generator installed after discussing with my electrical contractor and debating. He tried to talk me out of getting a generator and that whole story, which I'll share with you guys one day. But finally got a generator set up. I'm in the basement and I'm working, just getting my boxes unpacked, and it's storming outside, and I hear that crack of lightning and the power goes out. And I'm like, for me, it was like, yes. I listened to the transfer switch. I heard the generator start. I heard the transfer switch turn on, and I was still in the dark. Didn't put any lights in the basement on the backup power. And then I had to feel my way out of a dark basement. So in any type of power distribution system where you are going to have backup power, you got to think about all of those instances on what loads you want on this system, and don't put too many on that don't need to be there, but make sure you put the right ones on that need to be there that you didn't think about. So, but that process takes time. If you think about the transfer, it has to sense the source of power that is gone. That's your utility, more than likely, your utility source. it has to have there's obviously going to be a time delay from a transfer switch perspective, because it's got to get the generator started and get it up to speed. And then it's got to make sure and sense that source 2 is there and it's good. And then there might be other time delays involved, and then finally transfer to that source 2. And that does take a little bit of time. So in that process, you're going to sense the outage, and then once you're done with that, then you have to make the decision on when do you go back on normal power. So normal power comes back, you just don't turn it on right away. You got to make sure that it's a good, reliable source. You give it, there's a time delay in there that basically, and I believe some of that is programmable, where you say, how much time do I want to make sure that utility source is stable enough for me to transfer back over to that source, and then you transfer back over to the source. So it's a process, and if you can think about it, all of this has to go off right every time. And that's why 70B is very important, to make sure that we test these devices and we perform the proper maintenance on them, because the transfer switch has to work. I mean, you could have an outage, and if you haven't maintained that transfer switch, it may not transfer. That's a point of failure. You've got to make sure that transfer switch has been maintained and it operates and functions, and there are procedures and processes to make that happen. And we're going to talk about the code requirements around that. So let's talk about the different components. I can simplify this, for me, it's residential applications. The residential picture is a simpler one we can all relate to, no matter whether you're an industrial guy or a resi guy. The parts and pieces are pretty much all going to be the same. You've got a generator, obviously. You have your main panel. In some cases, you will have a transfer switch, and then you'll have an emergency load panel. So in your heavy industrials and in your commercial buildings, you won't just have one panel board. You'll have multiple panel boards that will be a part of your emergency system that will be fed from a transfer switch. I don't believe you ever would just power the entire building. You'll just do your emergency loads. If it's an Article 700 system, if it's an optional standby system, you put on whatever your pocketbook can handle, because the more load you put on, the bigger that generator gets. And then the other configuration, which is this one here, where you have the transfer switch and you are feeding the main panel from that transfer switch. Sometimes you'll see this in a residential application. What you can also do, that main panel may have load shedding capabilities such that, or the transfer switch may say, when I transfer and I supply power to this main panel from the alternative source, turn off the larger loads. And you can put some relays in to shed some loads so that your generator can start and maintain the power and you're not overloading it. All right, so let's talk. I'm going to focus on the generator itself. And this is when we get to our first quiz question. And we're going to see how smoothly this transition goes. So the first question is, are all of the requirements for generator installations included in Article 445 of the National Electrical Code? And the survey says 95 say no, 21 say yes, 16 aren't sure. So the right answer to this one is no. Not all of the requirements are the title of 445 is generators, but not all of the requirements are just in 445. So for those of you who didn't get this code, 60, 13, and 3, if you want to participate in the quiz while we are going through the presentation. So you can go to menti.com and type in 60, 13, and 3, and you can put in what you think the right answers are. So 103 of you have got the right answers. The answer is no, or 105 now. So the answer is no. All of the requirements are not just found in 445. We have Article 445, which is your generator and your equipment requirements. You've got Article 100, which has terminology. You have Article 110, which is your general requirements for the electrical installation. So your working space, all that stuff applies. Chapter 2, wiring and protection. Chapter 3, you've got to size conductors and you've got to use the right conductors for the application. And then you have, obviously, for special applications, special equipment, you've got your 5, 6, and 7 special occupancies. 5, 6, and 7 are the areas where you're going to go for other requirements that for those special applications. All right. So every generator installation is going to involve many areas of the electrical installation. And if you have fuel, think about it. If you've got propane, you have a natural gas, you have diesel generate, what do they call it? Diesel fuel. All of those can create hazardous locations depending upon how they're stored, where they're at, all the other good stuff. So there are a lot of different parts of the National Electrical Code that come into play during or around the installation for a generator application. And we have to remember chapters 1 through 4 apply to all installations. So if we go back to 90.3 tells us that, chapters 1 through 4 apply generally, and 1 through 7 can modify anything. So we can modify each other. So it's a, don't chase your tail, but you've got to know the entire NEC. So some of the important articles in my eyes, and you may have some that you think are even more important. I always think about, when I think about generators, I'm focused on 445, 700, 701, 702, 708. Those are some of the key areas that have specific generator requirements in the National Electrical Code. And we're going to talk about a little bit of each of those. When you get into 445, I know that some people have made the, I wouldn't say it's a complaint, but the observation that a lot of the requirements in 445 are covered by the standard, which I think is interesting, because it's technically it's pretty accurate if you take that perspective, because the National Electrical Code in 445, if I just look at, I should have had my book open to that section, but I didn't. But if you just look at some of the, you got the marking requirements, obviously. I mean, if a generator is normally, if you see marking requirements in the National Electrical Code, there are UL standards to back that up, as long as it's not a field marking, obviously. But if it says it has to have the manufacturer's name, the model number, if it has to have the short circuit current rating marked on the equipment, more often than not, you're going to be able to track that back to the UL standard for that product, and it's going to be a part of the standard. So if I look at 445, and if you look at the marking requirements in 445, they will echo very closely the UL standards. So the marking requirements tells me that I have to have the subtransient, transient, synchronous, and zero sequence reactances. Now, if you're not familiar with symmetrical components, you're probably scratching your head saying, what is zero sequence reactance? That's all part of the of symmetrical components, and that's your ground. That's the impedance that you would use when you're calculating ground fault currents. But in any case, power rating category, the temperature rise at the rated load and insulation system class. You have to put the available fault current for the inverter-based generators. Available fault current, I don't believe we can put that on from the factory. I don't know if there's any generator guys, but I highly doubt they can put available fault current. They can tell you what it can produce because they know the impedance. They are the source, but depending upon where that marking has to be, if it's on the generator, they can do that at the factory. But if there's anything with like service entrance equipment, I can't put the available fault current on that because of the impedance between that utility transformer and all that good stuff. So, and again, markings shall be provided by the manufacturer to indicate whether or not the generator neutral is bonded to its frame. So you can guarantee that this is a part of the requirements in the UL standard for generators. So there's a lot of information, and 445 is a small article, but a lot of what's in 445 is covered by the standard, but not everything. Now we have standby generators. These are your your portable devices, the equipment that, or I'm sorry, no, this is not your portable. I'm looking at the wrong slide. This is your actual, this is a fixed in place. You're going to wire this into your system. You're going to have an automatic, you're not going to have a plug and plug this puppy in. You're going to be wiring this into a transfer switch, whether it be on, this is a residential type generator, but your standby permanently connected to the facility would be your industrial, your heavy commercials, all that good stuff. The portable devices, these could be used for temporary power in residences. We can put an inlet with a manual transfer switch, and you just turn this puppy on, plug it in, and go. You'll see these on job sites a lot, things of that nature. There's been a lot of debate on the receptacles on these generators. Code panel 13 and I think it was 13 put some requirements for GFCIs on these. So there's been some debate over the years on ground fault protection with the receptacle on these generators. I don't believe I'm going to get into those details in this PowerPoint. I don't like to drag things through mud, but I know there's a lot of debate in that area. And that brings us to our next question. Okay, our next question is, do the requirements in NEC 445 cover the installation of portable, mobile, vehicle-mounted, and stationary generators? And the survey says with 141 respondents, 48 say no, 67 say yes, and 26 are not sure. What do you think? Think about that. Do the requirements in NEC 445 cover the installation of portable, mobile, vehicle mounted? So let's go, and this is how you figure this out. You go to 445 and you go to the scope. And what does the scope say? The scope says this article contains installation and other requirements for generators. And so, that's pretty general. If I look at 445.10 location, I'm thinking, okay, well, let's try location. Generators shall be of the type suitable for the locations in which they are installed. They shall also meet the requirements for motors in 430.14. So that doesn't narrow it down for me at all. My answer to this one is yes. It does apply to vehicle-mounted, mobile, portable, and stationary generators. So if I look at, I believe I have a slide that. So I read you the scope, and the scope doesn't narrow it down to anything. So if it's a generator, we're going to cover it. So I don't have anything in 445 that tells me otherwise. So my answer to this one is portable, mobile, and vehicle-mounted generators are a part of this installation. Now, we could say, I see Dawn is saying they are not installed, they are used. Article contains installation and remember, the scope of it says this article contains installation and other requirements for generators. So 445 is not just about the installation. There may be other requirements around the generator. For example, portable generators are required to have GFCI receptacles on them. It has nothing to do with the installation. It just says that the portable generators have to have GFCI receptacles on them. So I don't believe that you have anything in here with regard to, you have marking requirements. That's going to apply to generators. It doesn't matter if you're installing it or not. That's sort of where my head's at on this one. So portable, mobile, and stationary. But I do agree with you. They're used. They're not necessarily installed. They're plugged in, right? Like electric vehicle. Electric vehicles plugged in, and they put a new requirement for electric vehicles to have that outlet GFCI protected. that plugs in and connects. So if I look at 445, let's talk about the disconnecting means. So 445.18 is separated into 5 different sections. You have the disconnecting means, you have emergency shutdown of prime mover, remote energy, and all the way up through generators installed in parallel. The disconnecting means, again, it tells us that other than cord and plug connected portable generators, they have to have shall have one or more disconnecting means. And again, simultaneously, you have to open up all of the conductors associated with that generator, ungrounded conductors. And it has to be lockable open. Now, that doesn't mean you can't have it lockable closed. You can have a switch that is lockable in the closed position and the open position, but this just says that it shall be lockable in the open position in accordance with 110.25. They have to have provisions to shut down the prime mover. So when you disconnect, you're going to have to shut down the prime mover, which could be a gasoline engine, could be a diesel engine, could be whatever it is that's turning. It could be a propane engine, whatever that engine is. You have to be able to shut that down and disable those start control circuits. I'm just looking to see if there's anything else there that we should be bring about. Then you have the emergency shutdown, 445.18C. This is a remote emergency shutdown. 15 kilowatts, greater than 15 kilowatts, have to have a remote emergency stop switch to shut down that prime mover. And they tell you where it needs to be located in the equipment room, etc. Now, this one is relatively new to 445. I believe I know we made some modifications, and I believe the emergency, I know the last one, the remote shutdown was new, and this one is new for 1 and 2 family dwelling units. This was what I called the firefighter disconnect. And this was this is your emergency disconnect. So in 23085 in this cycle, if you remember back in last cycle, the firefighters came up with the idea that they needed this disconnect on the outside of residences. But I don't know that that's where they want to stop. But in any case, they wanted a disconnect so that they can kill power to a facility, the residential home. But I know a lot of some of the examples that I've heard of are not just dwelling units. So I'm envisioning that maybe we're going to have more discussion on this in other than dwelling units. But in 23085, we have a requirement for residential applications where they have to have a disconnect on the outside. And what we had to do was, when they made that change, they had to go back and address 445 to put this emergency disconnect. They don't call it a firefighter disconnect anymore. They call it an emergency disconnect to shut down the generator, because you don't want to kill power to the residential home so that you can go in and do what you need to do in a safe manner and then have the generator turn on, right? And then they also had to address storage battery installations in 480. So those two other sections, and 445.18 is what we were just looking at. So this is the language that they put in 23085, that you have to have a service disconnect. It has to be marked as emergency disconnect. You have to have it marked as emergency disconnect, meter disconnect if it's not service equipment. And then you can have an overcurrent device out there, like if you have a breaker in a box or a fusible disconnect that's not the service equipment, you can still use that in this regard and have it not be the service equipment, which I know there are a lot of people that just want to remove 3. And I believe we started a TIA around this one, but I'm not sure where that has ended up. It's probably on my plate to get done, but in any case, for the task group that I'm working on. But anyway, this drove a change in 445, which recognized that we need to kill power for these first responders. It's not just the firefighters; it's anybody who's responding to that structure. And so you see it in 230, you have it in 445.18 and 480.7. We didn't have to hit photovoltaic systems because there's already a rapid shutdown requirement in there. And also, when I kill power, Unlike a generator, my PV system, if it's an interactive inverter, will shut down automatically, so I don't have to worry about it feeding into the system. So that's just just to keep your awareness on 445.18, and this will only affect 1 and 2 family dwelling unit applications, at least now. But in my opinion, stay tuned, because I think you're probably going to see. I'd be surprised if you didn't see public inputs for the 2023 cycle that expands that. Then there's also in E, this talks about parallel generators. You want to isolate the generator output terminals, and they made a change. I believe it was in the 17 cycle. I don't see it indicated in this one, so I believe it was the 17 cycle that added the that noted that you didn't have to locate it at the generator. You could locate it wherever you need to locate it. So that was some relief that was given. I believe that was driven by the consultants. There were 2 consultants on panel 13 that drove that one. All right, so testing and maintenance. The NEC has some requirements in Article 700. 700.3 is titled Test and Maintenance, and which I know some people have a hard time digesting that, because the National Electrical Code's an installation requirement whenever you're installing equipment or working with equipment like that. And is it a maintenance document? That's what we have 70B for. But in any case, we have 700.3, which talks about actually conducting or witnessing the testing, periodic testing, the maintenance, the records, the fact that you should be testing this under load, and that includes the transfer and all that good stuff, and then making sure that it's all functioning properly. So there is a requirement in 700.3F that talks about a permanent switching means between alternate power source and the temporary power source, allowing for maintenance of permanent generators. So what they did is in 700, I know there was a discussion at panel 13. One of the, I believe he was out of Seattle, Washington. I cannot think of his name right now off the top of my head. But anyway, he brought up some instances where we had during maintenance. I want to make sure that I'm speaking about the right requirement, because they put a requirement in that you have to have a separate input and a switch, so that you can switch to portable temporary power. And I believe that's this section. I'm just going to get my bearings here a second. Yeah, that's what it is. So they brought up cases where they were pulling maintenance on the generator in a healthcare environment, and also in a Article 700 type of system, where they were pulling maintenance on the generator. It was out of service. That was the only generator that they had, and they had an outage, and they had to secure a temporary power, rewire it, and get it in place to provide backup power, because their primary backup power source was gone. So in any case, so now the code requires that we have provisions for that portable. When you only have that one generator, I believe that's the way it's written. It says if the emergency system relies on a single alternate source of power. So if I've only got one backup source, I need to have a permanent switching means to be able to connect to temporary power, a temporary generator, should I need it, while I work on my backup power source, doing maintenance or whatever it is that I'm doing. There was also in the 2020 cycle, I'm looking for it, there was some forgiveness of ground fault protection of equipment while you're in that maintenance mode. And I don't know if somebody on there knows that section number off the top of their head, but in any case, you have, I think, 90 days or something like that, 3 months, that you can work without ground fault protection of equipment, GFPE testing. I never realized how hard it is to to try to get through this, read and talk at the same time and try to find what you're looking for. But in any case, I know that's in there. All right. So anyway, this was a new requirement. I thought it was new in the 17 code, but it was new in the 17 code. They made some changes to it in the 2020 cycle. I believe the changes were very minor. So that's the way that goes. The provisions for to mean connecting a portable, all provisions. Yep. So that's what they're doing. They think they added a figure. All right. Okay. So transfer switch with cam locks can be used. They have solutions with an integrated safety switch and cam locks and whatnot. So there are a lot of different ways to skin this cat. In the way the language reads, again, if it relies on one single alternate source of power, which will be disabled for maintenance or repair, the emergency system has to have this inlet and an availability for portable power backup. So capacity and rating in 708.22. Before I get it, so the other is 700.4. This is 708, but for some reason I don't know where my slide went for 700.4, but I had a slide on 700.4. There's a new requirement in that section. Talks about 700.4 is the capacity and rating. It's in Article 700. We have a similar article in 708. But it says the emergency system equipment shall be suitable for the available fault current at its terminals. So that's that's from a short circuit current rating perspective, withstand close on rating for the transfer switch, all that other good stuff. But then there's a discussion in here about capacity. An emergency system shall have adequate capacity in accordance with Article 220 or by another approved method. I think my slide on that is later. I get into the load calculations, but in any case, your backup power system has to be able to supply the loads, and they made the change to point back to Article 220, which could be a good thing or could be a bad thing depending upon how you look at it. I know that the original intent or some of the discussions around that was that 220 will probably cause you to put a bigger generator in than what you actually need, because there's some changes in Article 220 that we went through to help recognize the fact that we're using more efficient loads like LED lighting and things of that nature, but it's still not there. You may be designing to the latest ASHRAE standards or the latest version of the energy codes and making all of these great decisions for low profile loading, but you're not necessarily getting credit for it in 220. And the concern was that you could have too big of a generator and too light of a load. That could be ungood. You want to make sure you get that sweet spot with loading the generator. But in any case, in 708.22, it does talk about portable, temporary, or redundant alternate power sources shall be available for use. But what you don't see in 708 is the same language that we see in 700. So, which I thought was interesting. In 700, they put this requirement in for this separate inlet, and I don't see the same language in 701. Now that's a legally required system, but I don't have the same requirement that I have to have that second input. And in 708, this is the best I could find, is the portable temporary. And so unless someone out there knows a little bit more than I do about some of these requirements, I don't see the same requirement in 701 or in 708 that says I have to have a separate inlet for my temporary power when I'm doing maintenance. I've got maintenance requirements in here. There's test and maintenance. Testing under load in 701. I'm looking in 701. I've got testing under load. I've got written records, maintenance requirements, testing periodically. And it talks about, testing periodically on a schedule and the manner approved by the AHJ. and all that good stuff. I got the capacity, and I've got information about transfer switches, but I don't have the same requirement on the inlet. So maybe a good idea for public input. I don't know. All right, so sizing the generator. That takes us into the whole discussion point of sizing the generator. I'm just going to look online. 215.10.3. This permanent switching means requirement has exceptions. Yes, it does. Ryan's referencing 215. I don't know if that's an old one. 215.10. 215.10 exception 3. I'm just looking to see what you're talking about there, Ryan. 215.10 ground fault protection. There it is. Thank you. That was what I was looking for. It wasn't back there in 700. So in 215.10 exception 3 says if temporary feeder conductors are used to connect the generator to a facility or repair maintenance or emergencies, ground fault protection of equipment shall not be required. Temporary feeders without ground fault protection shall be permitted for the time period necessary but not exceed 90 days. Hey, I got the 90 days right. I just couldn't remember the section. Yeah, so Thomas Hunt says this permanent switching means requirement has exceptions. So I don't have the actual code language up there, but let's take a look at that in 700.3. 700.3F. This is your permanent switching. The exception. The permanent switching means to connect a portable or temporary alternate source of power for the duration of the maintenance or repair shall not be required where any of the following conditions. Now, when they say any of the following, that means I've got 4 conditions, any one of those. I don't need all of them. Number 1 is all processes that rely on the emergency system source are capable of being disabled during maintenance or repair of the emergency source power. 2 is the building or structure is unoccupied. No kidding. And fire protection systems are fully functional and do not require an alternate power source. Boy, I'm getting old. I got to put this out this way. 3, other temporary means can be substituted for emergency system. Other temporary means. All right. And 4, a permanent alternate emergency source, such as but not limited to a second on-site standby generator or separate electric utility service connection capable of supporting the emergency systems exists. So those are your 4 exceptions to that requirement. And if you meet any one of those, God bless you, you do not have to put that in there. All right. Okay. Let's keep going. Sizing the generator. We're going to size it up. Generators, like transformers. This is a quiz question. Generators, like transformers, have no requirements in the NEC for sizing them to the load. And I believe that is a true or false statement. Wow. You guys are going to love this. Oh, it was 64-64. It was split down the middle. All right, so 64 say true, that generators are like transformers. There are no requirements in the NEC for sizing them to the load. And 65 people say that is false. Very interesting. And there are 15 actual truth speakers who share that they do not know the answer. And that's perfectly fine. Well, let's take a look at this one. The false guys got it right. 65, these 65 are correct. That this is a false statement. And these 67, well, we love you. Thanks for participating. We'll give you a small toy off the bottom of the shelf. But these 66 can stand up, pat yourself on the back, because you got that one right. Yeah, that is false. Generators Generators should be sized to accommodate the load. Now, I was very all-encompassing on the word generators. So there may be 67 of you guys out there that may do nothing but portable generators and say there is nothing in the National Electrical Code for a portable generator to be sized to the load. That is a true statement itself. But if you are if you have a generator that's connected via a transfer switch, it's going to have to be sized for the load. So you do have to have knowledge of the load. In 517 provides capacity requirements. 517.31, 517.42 talks about capacity provisions to make sure that the generators are sized for the load. 695 includes capacity requirements when generators are providing power to electric motor driven fire pumps. Now, I'm just going to check that code reference, 695.3, because I want to make sure that I don't have that. I didn't check this to the 2020 code. I did, but I don't know that I updated this one. I want to make sure 695.3 is the right reference. Power sources, individual sources, on-site power generation shall be permitted to be supplied by on-site power generation. The source located, there's the electrical utility, capable of carrying indefinitely some of the locked rotor current of the fire pump. So yeah, so there are provisions in here for making sure that that standby generator supplies that power. I'm just looking, just reading through here. Good. I'm good. All right, so 695.3 is a good reference. 700.4, I remember them making changes, and I think they lined it all up with the .4, except for 708. I'm just going to double check my 700.4 reference. I believe that is accurate. 700.4, capacity and rating, yes. And in 701.4 should be capacity and rating as well. And that is still accurate, yes. So, so we have requirements in Article 700, 701, 702, and 708 that have requirements around the capacity for the load. And, you know, you might say, well, you know, 702 is your optional. Why would they care in an optional standby power system that your generator with the transfer switch? Because remember, in 702, I have a few ways to serve that load. I can put a portable generator in. In that case, there's no requirements in 702 that I have to size my generator for the load, because I'm going to end up plugging it in. I'm going to be there. I'm going to plug it in, and I'm going to be able to turn loads on and off if I have a problem with the generator. But in an emergency, but in an automatic transfer in that 702 system, there were provisions, and I can't remember the code cycle. It was definitely not the 17. It may have been the 14 or earlier. I can't remember which one. It was around the Katrina time frame, I believe. What they learned was down and around Florida, Louisiana, and all those different areas where they evacuated people. They told them to get out. They got out. They had backup power systems because why? They had, they had freezers. They had maybe some exotic fish on those. But they would return, and they found out that transfer switch and the generator did not do what they thought it was going to do. And it was shut down because it wasn't sized for the load. And so that drove changes in and maybe Ryan, you remember the code cycle, but I can't off the top of my head on what drove that, what year cycle that was in. But they made it a requirement for Article 702 systems to when you're using an automatic transfer switch, you have to size that generator to the load. So Dawn Gannier and Ryan Jackson, I know you guys are feverishly opening your old code books. Or maybe not. You're going, I'm going to let Tom die on the vine. 700.4, this is the language that you see. Capacity, actually, 700.4. 700.4, they added in the 2020 cycle and rating. So this is 17 language. They made some slight changes to A. In the 2020 cycle, it says the emergency system equipment shall be suitable for the available fault current at its terminals. Shall be. So they removed that first sentence and they created B, which is called capacity. So A is rating. So they took the second sentence and said that is really a rating. And the first the first sentence was the rating, and they made us so the A is rating and B is now capacity. And then what they put in for capacity was basically emergency system shall have adequate capacity in accordance with 220. So those were two different changes, and that's a new section, and that puts you back to 220, which will change how you do business in regard to calculating your loads. And I know I just had a call, I can't remember who it was recently, that called me and said, who the heck put this requirement in 700 referencing Article 220? Because I'm on panel 2 and we covered the Article 220 stuff. And their comment was that it's driving larger generators because of how we do our calculations in Article 220. So something to be mindful of. They're pointing you back to 220, which may be depending upon how you look at it, could be a good thing and it could be a bad thing. So, but in any case, I think the selective load pickup, B is now C, and that did not change. 2008, Don Ganir is saying 2008 was very clear language for Article 702, automatic transfer switches. So that's when that went in, was 2008, a lot further back than what I recalled. Man. 701, capacity and rating. I'm going to make sure and see if they changed 701, if they split that up as well. 701.4, yes, they changed that, but it says capacity and rating. But what they did was they reorganized that in the 2020 National Electrical Code. You now have 701.4 capacity and rating. You have A is rating, B is capacity, and C is load pickup and load shedding and peak. So they mimicked what they did in 700, and in the capacity, again, they reference Article 220. And then, and this is 702. Remember now, 702.4, 702 is your capacity and rating. That didn't change. They have available, not short circuit current, because remember in the 2020 cycle, we got off of short circuit. Now we're on the fault current bandwagon. So 702.4 available short circuit current is now available fault current. And then they have system capacity. The change, they did make a change in the automatic transfer switch. They put it back to Article 220 or by another approved method. Oh, look at that. So in 700 or in 701, they put you straight back to 220 or an approved method. So you do have an Article 220 or another approved method, and they did the same thing in 702.4. Have to have it sized for the load in 702. All right, and then 708. I'm going to just double check the language because I didn't update this. I don't believe, well, obviously I didn't update it with regard to the 2020 code. 708.22 is a good, accurate reference. Capacity of power sources and capacity of power sources. Capacity and rating. It doesn't look like we changed anything in 708. So all of that language is still legit. Okay. 220.87. Oh, yes. 220.87. Alfeo. Alfeo on my tubers, one of my tubers. 220.87. Let's just take a look at what 220.87 says. It's your determining existing loads in 220.87 and its exception. There's so this is if you're adding a generator, obviously, to an existing installation. There's an exception. If the maximum demand data for a 1-year period is not available, the calculated load shall be permitted to be based on the maximum demand, the highest average kilowatts reached, and maintained for a 15-minute interval, continuously recorded over a minimum 30-day period. So you need 30 days worth of data. That's one exception. The other, there's a new exception in there. If the feeder or service has any renewable energy systems or employs any form of peak and load shaving, this calculation method shall not be permitted. So in any case, that doesn't apply to us. So yep. So there's a 30-day for an existing if you're adding a generator. All right, 708 didn't change, and that gives you that picture. So what I did was I just basically again just went through some basic concepts around sizing for the load, watts and DC. Your AC, you have single phase. You got to remember, if you have a single phase generator, 3-phase generator, there's going to be differences in your calculations and your math there. I talk a little bit about horsepower and watts. There's your 746 numbers. Okay, so you can do a calculation method. Determine which circuits will be connected to the generator. Categorize all of those into groups, static and rotating. Obtain the running watts for each of the devices from its nameplate. And for rotating loads, you have to have the starting watts for each device as it's listed on the nameplate. So you create a table. Got something in mind. Create a table for running watts and starting watts, and you get those totals for both of those. And so you have your running watts, you have your starting watts. If your generator is being sized for emergency or standby, then you have 30,834 watts or a 35 kilowatt. You have to be able to supply that load because you have to be able to size and energize all of those loads simultaneously if you're in those types of applications. So your total watts demand is your running watts plus your starting watts. For optional standby systems, this is when you can, again, go back to your traditional methods. You can do your running watts and your static loads to get your largest starting watt load, add the running watts of the largest starting watt load to the total of the running watts. You get, again, you're getting two different numbers, and then you're doing the math to calculate what your generator size is going to be. Usually, if you're on these optional standby systems, you're pretty much probably going to know. I mean, it's easier just to do the whole house. You grab those biggest loads and go back to Article 220 calculations, square foot, all that good stuff. But again, it's gonna drive you into a larger generator than probably what you want in those applications. So you're going to either employ some load shedding on those larger loads or put a separate sub panel in, and then you're going to be serving specific loads. So it's easy. It's pretty easy to do that calculation. All right. Basic calculation methods. That's your kilowatt requirements. Article 220, if you do the system capacity method, which I think that's what we were just talking about, that was a reference from Alfio. You go back to 220 and you can size without any of the demand. You have the exception that you can leverage. Look at your peak demand, or you can look at your energy data from the energy bills to come up with what your total usage was for that facility. You can employ that measurement method over 30 days. This is just basically looking at your billing history method. It's under 220.87. I believe that section is still accurate. I just want to make sure 220.87 is still accurate. This is the nice thing about taking an older presentation and some older slides. You can document whether or not you need to update some of these section numbers. Yep, that's the one that we just referenced, 220.87, and there's your existing. And so you can use your bills, or you can do your measuring, right? So you get your kilowatt hours or your demand, and use that demand value for your calculating what you need from a size of a generator perspective. So there are various ways to get to it, and you have more flexibility, I believe, in your standby systems. You're not legally required, or you're optional standby system. I couldn't think of the word optional standby systems. And you have then what you would have, like say in your Article 700 systems. So again, you would I'm just giving you some examples. So, largest starting load you might want to think about. You may not have that on your billing statements. And pick out your large loads in that structure. If it's like a residential, it's a lot easier than it is in your commercial or in your industrial applications. All right, I'm looking at the chat session up there on the tube land because the next slide is a question. I'm going to put the question up while I look at this. Spoke to one of the CMP members at an IEI section meeting. It was 702 capacity needs to be completely revisited as the concerns that drove it don't exist anymore. That's interesting. Yes, Dean, Article 220 is very conservative, and that's the concern a lot of people have when we start referencing Article 220, that you're going to have larger ATSs, larger generators, and then the question is, the concern really in that is, do you have too light of a load for that generator? Does not look like any specific incident was used in the substantiation for the 2008 702.5. I remember I was sitting around the table when that was going down in the National Electrical Code, Dawn, and there were what was used a lot. I know there were examples of when people left their houses, the generators were on, the automatic generator turned on because of the natural disaster that was coming through. It wasn't sized to the loads, and then it just bogged down, shut off, and they lost a lot of food. They lost expensive fish and all these other great things. So, the code is for life safety and for equipment and for property. So in any case, just looking back through some of those chats, I'm going to look at my chats from 517.31D. Also has sizing requirements for healthcare facilities. Thank you, Kevin. Absolutely. Your question should state for emergency generators, not normal generators. You're only sized for the load for emergency. Not really. Stephen, we just noted that you have to size the generator in a 702, which is not an emergency generator. 702 is your optional standby systems, and our capacity for an automatic transfer switch. If you're employing an automatic transfer switch, it says where automatic transfer equipment is used in optional standby systems shall comply with 702.4B2A or B in accordance with Article 220. And then it says A, full load, the standby source shall be capable of supplying the full load that is transferred by the automatic transfer switch. Or B, you can have a load management system. So, and I left it general like that for that reason, because a lot of people forget about an Article 702 system. All right. What NEC code requires sizing for loads on on-site power in parallel with utility not used as emergency? They are not sized to loads, but for load relief. I would refer you back to 702. If it's not a 700, a 701, a 708, it's going to fall under a 702 as an optional standby system. And if you're employing a transfer switch, now if it's a portable generator, no, you don't have to. If it's a standby generation with an automatic transfer switch, you absolutely do per the code. All right, so is the responsibility for compliance with the requirements in the NEC Article 445 an installation issue, a product manufacturing issue? This one is a no-brainer. It's an installation issue. 101. I don't want to say no-brainer because we got 45 people that said it's a product issue and 20 that said it's not sure. So we've got 45 people that you got to remember this is an installation issue for those generators. And I know, Dawn, you're probably sitting there going, see, it's an installation. So it doesn't apply to a portable generator. It doesn't apply to these other applications. But in any case, 103 got that one right. So to comply with the NEC, all requirements of 445 are met in the installation. So that's it's an installation issue. It's the installation code. Okay, let's talk about placing the generator. Does the NEC require a grounding electrode to be provided at each generator? Ooh. Survey says 144 people responding. We've got 64 yeses. We have 68 no's. And we've got 12 I don't knows. Well, so my answer to this would be not generally. So I would say it depends. It says, does the NEC require a grounding electrode to be provided at each generator? I would say it doesn't require it at each generator unless, right? So you have to think about how that generator is configured. If the design of the system says that it is a separately derived system, then you're going to have a grounding electrode connection. And if the generator is determined to be a separate structure based upon the rules of the laws that we have for feeders and whatnot, then if you define that as a separate structure, I believe the changes in the 2020 and some of the changes in the 17 will help you get away from that. So it depends. It really does. If you consider it a structure, then yes. I mean, if you put an electric vehicle charger out in the parking lot and your inspector says that's a structure, then you're gonna have to put a grounding electrode or a ground rod there. So it depends on a lot of different things there. It help and one of the things we have to remember is and this will lead us into a discussion around separately derived systems as well. But in any case, and I have more on that a little bit later. So I would go with no on this one. That's how I would have answered it. I would have said no. So I would have been in that bucket of 70. So for the 65 that said yes, use the chat. Tell me I'm wrong, and get those to get that dialogue going. So only install units outdoors. Indoor installs void warranty. So if you install generators indoors, you've really got to look back to the manufacturer's instructions and understand some of the requirements and the myriad of requirements that you need to consider if you decide to put this indoors. Some of the most of the instructions will tell you these are outdoor types of things. We didn't just have this. We had this issue at an installation a while ago where that generator was installed inside in a very expensive home, and they had to make some major changes because they were violating some of the basic rules there. So there may be local laws regarding the location between that generator and the fuel source and the fuel supply. And I don't know, Elfio and maybe Abbas, Mr. Abbasi can elaborate a little bit more on that on the chat windows. I know that you guys are probably very in tune with that. And I know there were some challenges in New York City about moving the generator separate from the supply source. So I don't know if you had any comments on that. It'd be great to see that in the chat. And so 445, and then there's requirements in 430, because remember, 445 points us back to 430.14 that talks about ventilation and maintenance and open motors or generators. So generators and motors, very similar in construction, similar issues going on between both of those. All right, and then there's if you're putting these things outdoors, you've got to be mindful of where you are in regard to windows and things of that nature. They're based upon fire laws, and there are rules with regard to fire. There's exhaust coming out of these. You don't want that going into the house or into the structure. So there are requirements for how far you need to be, either from an underhang for the roof, because you think about it, some of that exhaust can go straight up into the house, into that upper attic area, and filter its way down through the house. There's requirements specifically for like liquid cooled, 5 feet of clearances on all sides for airflow. I know, on a lot of these installations, uh, homeowners and others, they'll say, boy, those things are ugly. I want to put fences around them. I want to put bushes around them. So they'll do things to hide them. And when they do that, they end up violating National Electrical Code and listing requirements, because they'll tell you, um, like there's other reasons why you don't want to put things around that. You need air. You need air circulation. You might have to be worried about heat, things of that nature. So there are concerns around weather concerns. There's concerns about conditions. I've gotten pictures. I didn't take them, so I didn't put them in here. But I have pictures of where the gutter, the downspout comes right down over top of the the generator installation, which is not good. So again, and you have to have your signage up. Follow the manufacturer's instructions about the pad that you have to have underneath these structures, the location. Be mindful of your if you're feeding conduit up through that pad, make sure you've got the dimensions right, and that the pad is the right distance from the structure. Don't pour the pad and then think, well, my generator is going to go on this side of the pad, and they put it in a different location. So, there are a lot of detailed instructions. Or you could be like this poor guy who, when I looked at the size of that pad and the size of that generator that's going to that structure, it doesn't look like a very large, very large home. I don't know. It's got a small air conditioning unit there. I don't know if he's measuring it because he's going, holy crap, what did I do? It's too big. Or maybe he had plans for a much, much larger generator. I don't know. But in any case, think about location when you're mounting and installing that generator. So let's talk a little bit about the control and the power wiring, the power and control conductors. So we're going to go from the generator. Now we're going from the generator into either to the transfer switch. And we've got another quiz question. Before I'm going to put the question up there, but whoops, I just lost something. Hold on. I'm going to get my Alfio had some NFPA. So Alfio L referenced NFPA 37, a standard for the installation and use of stationary combustion engines and gas turbines. Great reference document. You're going to want to follow those rules too. That's the thing. When you get into generator applications, you're going to get into a lot of other standards and requirements, not just 445, obviously. Al mentioned that it's not a structure. See the definition, other than equipment. That's very good point, Al. Absolutely. All right. Just looking at, remember my YouTubers are a little bit behind us here. Mr. Abbasi, 330 gallons of fuel is the maximum amount of fuel that can be stored at any floor in a building. Indoor generators must have a 2-hour rating enclosure as well. Absolutely. So when you end up putting something inside that building, if it's rated for indoors, you have building code, you have fire code, things you have to think about. And then to your point, Mr. Mather is referencing that there are limitations of how much fuel that can be stored inside of that building on any floor. Because remember, in New York and in other areas, they're moving that generator and everything, and they're getting electrical equipment outside of the basement, which can flood, and moving it higher up into that structure. So that presents some unique challenges. Very good dialogue going on YouTube as well. Then look at David Platt just put a note on WebEx about Department of Energy, a good source for that topic. Yes, absolutely. And he provided a link in the chat session as well, energy.gov. And what I'm going to do, David, is I'm going to copy that, and I'm going to put that out there because my tubers can't see. Oh, Control V. I don't know if that worked, but I'm just going to, I don't know if that works or not. Copy. And I'm going to put it out there on YouTube. Control V. There it is. That worked. All right, I got two keyboards. I got one for my cell phone, and I got one for my, I can get rid of one. All right, 705 part 3 for generators, but no capacity for sizing requirements. Interesting. 705, that's your interconnected. All right, let's take a look at the question. The circuits installed from a generator to the building, structure, or utilization equipment are classified as what? Oh, I'm curious on how good you guys are on this one. Ooh, doggy. Survey says 145 people. 58 say service conductors, 70 say feeders, 7 branch circuits out there, and 10 I don't knows. All right, the right answer for this is feeders. So the key to this is to understand the definition of service conductors. I'm going to open my national, and I know everybody out there, all however many people are online and on WebEx, are going to be looking at their code book. And I want you to go to service. Let's take a look. Service conductors. Service conductors. It says the conductors from the service point to the service disconnecting means. Well, what's a service? Service drop, service entrance, service equipments. What is a service? Service are the conductors and equipment connecting the serving utility to the wiring system of the premises served. So if the utility does not own that generator, that is not a service. That is a feeder. So the right answer to this question is those are feeders. They're not branch circuits. They're not service conductors. They are feeders. So now, if I have a portable generator that only extend to receptacles mounted on the generator, those are branch circuits, right? Because that goes to the receptacle. But if you are supplying power to a dwelling unit, to a structure, those are not service conductors. Those are feeders, and they follow the rules to feeders. That's why it's really important to be able to qualify those correctly, because if you qualified those as service conductors, you're going to be going to Article 230 for the rules around that, and you don't want to do that. You want to be in 215 for feeders. They cannot be services because in Article 100, the conductors and equipment for delivering electrical energy from the serving utility to the wiring system, and that generator is not owned by the utility. Now, the ampacity of those conductors are basically how you calculate that is not less than 115% of the nameplate current rating of the generator. So you're looking at what you can output, and you're going to multiply that by you're going to increase that by 15%. You can size those by in accordance with 220.60 as well, and then again you have to all of your conductors that have to carry ground fault currents shall not be smaller than what's in 250.30A. So there are some rules around the ampacity and sizing of your conductors that are coming. That's your power conductors, basically, coming out of that of that generator. All right. So then let's see, what do we have? What am I doing next? So the other thing is important is you have to make sure that you can read the nameplate data. So nameplate data is very important when we're working through this, and there might be some people on either YouTube or on WebEx that can read that nameplate, but I can't. You know, the nameplate's going to give you a lot of information. It's going to give you your voltage. It's going to give you your amps, and this is on your controller. So actually, that's on your generator. So where the generator set is equipped with a listed overcurrent device. The conductor shall be printed to be so this is getting into the tapping of those conductors. So if your generator has an overcurrent protective device built into it, which a lot of these do, excuse me, you can tap, and you're going to be following the rules of 240.21b. Now you have your control and power circuits, and they have to be you're going to have those in separate Woo, raceways. Underground. If you're, whenever you install those, if you're installing, if it's going underground, you have to consider the environment. If it's wet locations, and you have to have how many conductors you have in there. You can't forget about chapters 1 through 4. If you're penetrating into that building, you're going to have the ceiling requirements. Follow the manufacturer's instructions on how to wire these things up. You're going to have control wires that's going to initiate the start and stop of those of your generator, and it's going to be through your transfer switch. The instructions and manufacturer's instructions have really great detailed information on how to land those conductors, where to land those conductors, and you have to understand the terminations associated with all of that. In 700.10, we've got our generator control wiring. This is 700.10D4. I believe that's a new requirement in the 17 cycle, if I'm not mistaken. 700.10D4 talks about 700.10 is your wiring of emergency systems, and your D is fire protection, and then D4 is your generator control wiring. So that's sort of the navigation that you're going through. Yeah, I believe that was a 17 code cycle. You have to monitor the integrity of that of those control wires in those applications. So you have to monitor whether or not they're broken, they're disconnected, or they're shorted. And it did go. Yeah, there it is. It's the 17 code initial. And there was a TIA, I believe, when they initially published it. It said continuously monitored. And then there was a loss of integrity for remote start, so that created some complications, and there was a lot of negative feedback on that. And I believe they came out with a technical interim amendment that fixed that language, and the language that you see now in 700.10D4 is still there. In the 2020, it was not changed, and it specifically speaks to that your remote start circuit has to be monitored for broken, disconnected, shorted wires, and it has to identify the loss of integrity initiating a start on the generator. And I have some slides, I think, around this topic. There it is there. So this is your traditional two-wire start circuit where your engine again, it may unnecessarily start under certain conditions. If you have a shorted wire, if you have a broken wire, there's supposed to be a short right across here, which is not showing up. So on the shorted wire, so for example, if I accidentally, if I short this wire this way, if I short that, I could cause a start on my engine generator. And if I have a break in my wire, I could start. So I could accidentally, something could happen to the integrity. It's going to start it. So basically, the solution, basically, they're looking at some, how can we do this in a simple manner? This is your standard Form C contact, where you have a single pole, double throw type of logic that goes on, where you have no voltage is normally closed. If you apply a voltage, it's normally open. And instead of just bringing 2 conductors, you're bringing 3 conductors, so that you can walk through all of the different possible states. So with normally open contact and the normally closed contact, the signal then energize the generator to start. If you're basically monitoring 2 inputs, I hate when these things don't automatically just pop up. So again, this is a really simple solution that I believe we're employing, and there probably are other people out there employing the same type of technology as well. That if you have a no start signal, identifies a state open and closed, basically loss of the circuit integrity, it starts the engine. If you have an open circuit, you can start that engine as well. So these are just different ways to accomplish shorted wires in the normally closed loop, broken wires in the normally open loops, and ways to meet the National Electrical Code requirements. You have to be able to indicate that when you have this issue and initiate that start. So if you have closed and an open and input 1 and input 2, there's no corresponding action. If they're both open, then you start the engine, and because you've lost your circuit integrity. If you have a closed position, you have a loss of circuit integrity. You're going to start that engine because you have a loss of integrity. So the key is, how do you determine and recognize that you have a problem in the conductor, that it wasn't initiated by the transfer switch, that generator started because you lost the integrity of the wiring to that generator. So this solution is very simple, it's very reliable, and it can be employed in multiple transfer switch applications. So this is sort of how we've been employing this logic. Unfortunately, there are solutions on the market that put modules in between the two that don't technically meet the National Electrical Code, but some inspectors are permitting it. But you want to keep something, again, my philosophy, keep it simple, stupid. And often simplicity brings lower cost as well, and you have a better reliable solution. But on our controllers, we have these normally open, normally closed contacts. There are solutions out there that employ modules. And if you read the requirements in the National Electrical Code, tell you that you have to monitor the integrity of the circuit. And if you're putting modules, you're only monitoring the integrity of a portion of the circuit, because these modules are only going to monitor this portion of the circuit. It's not monitoring what's on this side and what's on this side. So you're not getting a complete monitoring to meet, which is the language of the National Electrical Code. So if you look at an installation and it's employing modules inside the circuit somewhere, they probably paid more money for it, and they probably have pulled an external power supply to it, and they have introduced more failure points to the entire picture, and it does not meet the National Electrical Code requirements of only monitor, because it only monitors a portion of the circuit, and the code tells you have to monitor the entire circuit. So, and I will put links on my YouTube site to more of the information on that, so you'll have that. So let's talk a little bit about the transfer switch. You have UL 1008, which is the standard reference that we always use. There are two other outline of investigations for over 600 volts. And then when you have meter mounted equipment, that's some new solutions that are on the market. When you get into the transfer switch, you're really worried about how fast can I get this transfer on the road, and do I meet the National Electrical Code requirements for 700? So 700 has a 10-second rule. 701 legally required, you have a 60-second rule. 702 obviously there's no time requirements for optional standby systems. And then in 705 again, there are some requirements about operating in parallel with the primary sources, because that's 705 addresses interconnected power production sources. So you have these rules, and this is going to be driven not only by the transfer switch, but how quickly you can get those generators started. So you've got to detect the loss of voltage or loss of power, and then tell that generator to start, give it time to start and transfer. And if you're a 700 system, you got 10 seconds to get that done. 701, you got 60 seconds. In 708, again, 708 points us back to 700 for that ATS. So you're back into a 10-second rule in 708. Here's the language in 700. Again, emergency systems, where essential to maintain life, etc. So these are, again, just regurgitating, and you could read your own code book. I'm not going to have to, and I think I even paraphrased some of that. The other thing is to remember, make sure you've got the right transfer switch. There will be listing marks, and they'll tell you whether it's an automatic transfer switch or a non-automatic transfer switch. They'll be listed differently. In some cases, I can have a manual transfer switch, say a UL67 panel board. You've seen those dead front covers that have the manual capability and move things back and forth, manually transfer over. You can have a UL98 switch that will act as a transfer switch, but verify that the labeling is correct. I've actually seen in some cases where people will try to make their own transfer switches and manual transfer switches out of parts and pieces. It has to be a listed solution. 702, load management permits downsizing that generator. That's an important aspect of it. And there are solutions on the market that either built into the transfer switch or, separate little enclosures that will automatically shed some loads for you. Putting in a smaller generator and only supplying loads that you need will not only reduce the size of the generator, which reduces your cost, it also reduces your energy, your gas usage, and all that good stuff. So you have active systems and passive systems. Your active systems will monitor the loads and do the shedding for you. Your passive systems, will only serve the dedicated loads that are connected. So interposing relays, there's ways to get that done. There's, very expensive transfer switches, and there's, I would not say you want to create these things in the field. If you're getting something inspected, the inspector is going to be either looking for a UL mark or say, okay, if you made this yourself, you've got to worry about you've basically created a UL 508 type of control panel. You're going to have to follow the rules, and they're going to be they could possibly require a field evaluation because the inspector is going to have to make sure that whatever it is that you're looking at adheres to the rules, and they use the listing requirements and the listing mark to make sure that the product's going to do what it has to do. So don't be making these things out in the field. Proper grounding and bonding. So here's the other question. Are circuits and systems originating from generators considered separately derived systems? Oh boy. We got 97 yeses. We have 27 no's. And we have, whoa. Sorry about that. We have 24 not sures. Boy, there's some confident people out there that say yes. And I would argue that it depends. The NEC permits, but does not require that generator be a separately derived system. Remember that I could, if I have a separately derived system, I'm going to disconnect all my premises wiring from the other sources and whatnot. So a premises wiring system whose power is derived from a source of electric energy or equipment other than a service. Such systems have no direct electrical connection, including a solidly connection grounded circuit to supply conductors originating in another system. That's basically a separately derived system. You got to look at 250.30 and 250.34 for separately derived systems and grounding. You're right, Ryan. That question as written can't be answered. You were probably one of the 99. So the thing is, you got to sometimes throw a little curveball. So that's that's an interesting topic. So 24087. Just before I get into that, the 24087 applies to these generator applications as well. If you've got a very large generator, that's 1200 amps and above. You're right, Dean. It should have been a depends, should be an answer on that, on a lot of those. But hey, what the heck. So 24087 does apply as well on these applications if the circuit breaker is 1200 amps or greater. And there are many methods to get that done. Arc reduction maintenance switches, zone selective interlocking, and all this good stuff. So, and that's all there to reduce incident energy. I know you have less arcing current. You have less current coming from a generator than, well, I'm going to say that, but in some cases you can have a lot of current coming from a generator. But you're going to want to make sure that your arcing current is cleared. When you get into services, 230.66, And 250.28 means you need to have markings in there that it's suitable for use as service equipment. And what this really gets into in helping us understand that main bonding jumper. And I have seen some transfer switches that didn't have the right wiring methods, right? That didn't have that bonding jumper in, and they required you to land the grounding electrode conductor on the grounding electrode. And that would be fine as long as that main bonding jumper is in there. But if the main bonding jumper is not there, then you're not permitted to put the grounding electrode conductor on that bar. You have to put that grounding electrode conductor over there on that ungrounded, or called neutral, or ungrounded conductor, which is the grounded conductor bar, the neutral bar. So that is when you put that over in, and then that's bonded to the system. But all of your grounded conductors have to be on the same bar as the grounding grounding electrode conductor, which connects to the grounding electrode. And you can't use the back pan or anything like that. And you don't want to make your own bonding jumper. You don't want to do that and try to size it and make your own bonding jumper. Again, when you get into switching the neutral is when you're going to determine whether or not it's a separately derived versus a non-separately derived system. And I've had installations where they had a generator, they had a ground rod at that generator, and it was bonded. And they said, well, I bought the wrong transfer switch because I'm not switching the neutral. And it's a separately derived system because I'm bonded over there at that generator. I have a grounding rod, etc. And they thought they had to buy a new transfer switch to switch the neutral. But in reality, all you need to do, because you don't need to switch that neutral, that is completely optional, as long as you don't bond the neutral at the generator to a ground rod. If you just separate that bond, then you can operate that as a non-separately derived system. Don't transfer the neutral. You're still bonded and connected to the grounding electrode in the service panel. Everything is hunky-dory and everything is fine, just like you have in that picture. But if you've installed it this way, again, and you installed the wrong transfer switch, you're not switching the neutral, just unbond it. Don't bond it over here. Take that bond. The instructions from the manufacturer will help you make that, figure that out, and you don't have to change the transfer switch, and you don't have to make any major changes, right? So separately derived versus non-separately derived. Don't get your shorts in an uproar if you accidentally bonded there at the generator as a separately derived system, but didn't buy a 4-pole transfer switch, switching that fourth pole. Because that's what you would have to do. You don't want to have it bonded and grounded at the generator and in the thing. And what's the better solution? I don't know that there is a better solution. I don't think there's anything wrong with a non-separately derived system from a generator perspective. Now, you can have a ground, if you love ground rods and you want to drive a ground rod out there anyway and bond it out there, you can do that. Nothing says you can't do that. You can for lightning strikes and things like that. But as long as you're grounded somewhere, someone else may in the chat may say, I think a separately derived generator is better than a non-separately derived generator for these reasons. Put it out there. So in this case, this generator says for standby service neutral floating, maximum load unbalance is 50%. Actually, that's neutral floating. That's in the wrong location. Is it for standby service? Neutral floating. Oh yes, neutral floating. That's the right thing. So this one tells us that they've not bonded that neutral. But if you want to install it as a separately derived system, then you're going to need to bond that. Now, temporary, like portable generators, that's the big hiccup with portable generators. Is what do? Do you bond that when you ship it? And then if I bonded it and your transfer switch is only 3-pole, then the homeowner is going to have to know to unbond it. If I don't bond it and then I use it in a as a standalone type of system, not connected to a structure, well, now I can ground it. I can put a grounding rod in there and all that other good stuff. But if it's not bonded, then it's a floating system. So I think you get in. You get into that world of debate with regard to the portable generators, more so in this, knowing whether or not it's bonded or not at the generator. Al pointed out, and that's a good point, large systems, ground fault protection of equipment works better on a separately derived system. And I would agree with that because you got to think about how those ground fault currents are flowing and whatnot. Yep. All right. Okay, service equipment 230. So because it's service equipment, you're going to have line side barriers, and we have those you have to meet the requirements in 230 for line side barriers. If it's service entrance equipment, we're going to have that line side barrier. That was just expanded in the 2020 code. Uh, 230.62, service equipment enclosed. Yep, I already said that. Contactor. Yep, I already said that. Oh, this is your bypass isolation. So in 230.62, barriers shall be placed in service equipment such that no uninsulated, ungrounded service bus bar or service terminal is exposed to inadvertent contact by persons or maintenance. And we have what we call a bypass maintenance switch, which I'll put the links to that. There's some videos that help you understand how that works. I'm going to get through some of this because we're coming close on time. I think I covered the transfer switch pretty doggone good and how it works. I'm just going to feed through here a little bit to see. Let me hold on. See where I want to go. Yep, we're coming to the end. All right, so hold on. So you have your automatic, your manually actuated, non-automatic, your 702 systems, your non-automatic transfer switches. You're going to find those in many applications. Again, you have the 7 factors, which I already talked about up front. And during that process, you're going to have a controller. You're going to have a brain that's going to conduct the transfer for us. Dual solenoids, transfer controls. Yep. So I think that's actually, I'm just going through the different parts and pieces now to help you understand the parts and pieces. I've got like 3 minutes left, and I believe I'm here at the end. This is just talking about, that sensing and the way the transfer occurs and some of the time delays that are in there. So that's an important part. You have to set your time delays when you are setting up your transfer switches. You have to understand, your emergency source, and you have to make sure that it can transfer in the right amount of time with all of the time delays that you may have installed. You've got to pay attention to the withstand close-on ratings, which will be determined based upon what is either inside or installed or upstream from that device in that equipment. So your withstand close-on ratings are going to be dependent upon the overcurrent protected devices upstream of that transfer switches, and with selective coordination requirements and things like that, you've got to think. Most of these are like 3-cycle type devices or 1.5 to 2-cycle devices. From a withstand capability perspective, but you may need for selective coordination 30-cycle withstand capabilities on these transfer switches, just primarily because you've got intentional delays upstream. So be mindful that if you're in a selective coordination world, you are putting intentional delays to increase the reliability of the power distribution system downstream, and you could have intentional delays that you're going to have the right transfer switch installed for safety's perspective. All right. I just want to make sure that I hit all of the questions, which I think that last one. Okay, non-current carrying metal parts of conductors not wired as separately derived systems are not required to be connected to an equipment grounding conductor, and that is false. That's perfect. We got 105 people got that one right, because remember, the equipment grounding conductor there is for voltage potential, for return ground fault path, all that good stuff, and you still have to bond everything together. You still have to keep that potential from a bonding perspective. So the equipment grounding conductors are still going to have to be there, whether it's a separately derived or non-separately derived system. And that was the last question for that. Right. Talk about in the beginning.